Welcome to the Real Python Podcast. This is episode 61. Would you like to move your data science project from a laptop and scale it up to the cloud? Would you also like to have snapshots of your project along the way so that you can go back in time or share the state of your project with another team member? This week on the show, we have Savin Goyal from Netflix. Savin is the technical lead for machine learning infrastructure at Netflix. He joins us to talk about Metaflow, an open source tool to simplify building, managing, and scaling data science projects. Metaflow addresses the needs of the numerous data scientists who work at Netflix. Machine learning is a key strength for the streaming service. They tried several existing tools to scale their own internal infrastructure, and after this experimentation, developed Metaflow. We talk about the history of the project and how someone could get started with the open source version. Savin also contrasts the costs of infrastructure as compared to data scientists and the cost of their time. This episode is brought to you by DigitalOcean's app platform. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Savin, welcome to the show.
Hey, thanks for having me.
It's kind of neat that you reached out after a previous episode where I was talking about in the project section with David about Metaflow. And I was very interested in the project and I had kind of played around with it. I'm not doing quite the scaling type projects, but I know a lot of people who do, and I've definitely worked in those environments. And so I was very interested in kind of what Metaflow is and what it can do. And maybe we can start a little bit there, for somebody coming brand new to this episode, what is Metaflow?
Yeah, so Metaflow is a data science framework that we have been building at Netflix for the last, 3.5, 4 years. And some of the problems that you outlined around, hey, here's a data science project. How do I structure it? How do I train my workflow? How do I keep track of the models that I'm generating? How do I access the data stored in the cloud, scale out my training processes, deployment, experimentation? It's supposed to provide an opinionated view in terms of how to approach machine learning engineering. And it's available as an open source project for both Python and R users.
Cool. I've dabbled in R kind of about the same time. I was working at a bank in Hawaii, and there were definitely two camps, even in our small organization. And there are things that I really enjoyed about R. I really like definitely the tidyverse stuff.
Yes.
Like that vocabulary a lot. I feel like it flows. And sometimes I had to have a cheat sheet to go back and forth between how I would do that and pandas and so forth. And I know those two projects kind of steal from each other a little bit, but I can appreciate that there are people that enjoy working in one platform or another. So that's nice that the project can work across both.
Yes, indeed. I mean, there's this excellent project called Reticulate that allows us to bridge the boundaries between Python and R, which is what Metaflow uses behind the scenes. And Netflix has invested pretty heavily in both the Pythonic and the R ecosystem. So we do have significant users who prefer to do their daily job in R.
Okay. And so there's quite a few people, a fairly large camp on both sides.
Yes, indeed.
So one of the things that I was wondering about is your background. I feel like from the conversations I've watched online and some of the conferences I've seen you talk at, you seem to have an interesting background just by the way that you're speaking about things. Do you have a bit of a background in data science along with the infrastructure side?
Yeah, so it's actually interesting because, when I started my career at that point in time, I was planning to focus more on applied machine learning. And I started my career at the startup where we had both data scientists and infrastructure engineers. And very quickly, I realized that to make any forward progress with any of the applied machine learning work, we had to first invest in pretty heavy duty infrastructure.
Yeah.
And this is, almost like 8 years ago, and machine learning engineering was not a phrase back then. And
Okay. Yeah.
so I had these ragtag skills where I knew a little bit of data science, I knew a little bit of infrastructure, and I found myself in the spot where I became the bridge between the infrastructure people and the data scientists. And throughout my career, that's the kind of role that I've enjoyed playing, essentially building infrastructure for data scientists to make them more productive.
Yeah.
Yeah. So I still remember, back then Hadoop was sort of like the shiny new thing. And now people have moved on to very different architectures. The style of work has changed significantly. The contract between data scientists and engineering teams, that has also evolved. So a lot of good things have come out, and my entire experience is just like the evolution that I've seen from pretty much a front row seat so far.
Yeah, I think about that as the field has gotten, I don't know, intensified, like the types of things that can happen inside of data science, and then the machinery of the infrastructure has become, in some ways, democratized, but in other ways allowed to scale to like kind of enormous sizes and so forth, that they have kind of moved apart a little bit, and you've kind of been in that push and pull there, right at the center of it with a company like Netflix, especially. I'm not sure how long you've been working with them.
Yeah, I mean, I've been at Netflix for close to 5.5 years now, and democratization it's a rather interesting point. Netflix runs almost entirely on top of AWS, and what that means is if there's a brand new startup, a 1-person, 2-person startup, they have pretty much access to the exact same set of infrastructure that Netflix uses internally as well. And that's pretty amazing.
Yeah.
Like 10 years ago, if somebody could have come in and said that, hey, you can get access to the same physical infrastructure that the Googles and the Facebooks and the Netflixes of the world are using, that would be pretty big deal.
Yeah. You mentioned that some of what Metaflow has built upon are some of the earlier projects that were kind of like thinking of similar solutions,
Mm-hmm.
and then you've kind of built on top of it, and then decided to contribute, this open source project out there for people to kind of build on top of it. And I'm trying to think of what the names of those earlier projects that were kind of the forerunners to some of the stuff that's in Metaflow.
Yeah, so I mean, if you look at Metaflow, right, like some of the ideas that it derives from, like Metaflow has this focus on a user essentially defining their work in the form of a directed acyclic graph. And that workflow pattern has been part of like many other Python packages. If you look at, say, Luigi, or if you look at other infrastructure pieces like Airflow and so on and so forth. So there is some amount of influence from those areas. And by and large, the role of Metaflow inside of Netflix infrastructure is not to sort of like reinvent what already exists. Both Amazon as well as Netflix have invested pretty heavily in some foundational technologies, and Metaflow essentially tries to build a collection on top of that in a very opinionated way. So what I mean over here is, say you are a data scientist and you want to train a model on a fleet of GPUs, which happens to be a very common use case for us. Now, many of the data scientists that we have at Netflix, they have advanced degrees in data science, but they don't have formal training in computer science. And now if you have to interface with the cloud, if you have to run compute remotely at sort of like, even a nominal scale, very soon it becomes a distributed systems problem. Simple issues like, how do I create a Docker image? What is a Docker container? How do I launch a Docker container on top of a Kubernetes cluster? How do I get my data within that cluster? Once the training is done, where is that model stored? Now, if you have, say, multiple people working on the same problem, How do I make sure that my colleagues can replicate the work that I have done so that they can build on top of it? So there are like a lot of these constraints that come about as people go about doing their jobs, which forces them to think about all the engineering concerns as well. And that starts to take them away from the data science world,
Right.
which is a little bit counterproductive, right? I mean, in many organizations, data scientists, they happen to be one of the most expensive resource, and we would ideally want them to focus on data science problems and not sort of like some of these mundane engineering problems. So then the goal is, can we sort of come up with an approach that builds on top of these foundational components, but then smoothens all the rough edges for our end users?
So I was thinking about all those components, and the tutorial that you have for Metaflow kind of walks you through, kind of working within the platform. I didn't get into the more advanced stages. I was just kind of in the first 2 or 3 kind of modules, kind of playing around inside there and kind of learning what to do. But the idea behind it is that you can build these reusable, not only the idea of like the images of like the Docker containers and having all that stuff set up, but you can have it almost in a way, have your data science project sort of packaged together, not just like, okay, I'm using these particular Python modules and I need this particular set of data, but it kind of can combine all those things together. Am I thinking of that right? That the idea that the project is saving not only what the language parts need, but the infrastructure needs beyond that.
Yes, indeed. Like if you look at, say, any machine learning project, there's the actual code that the user writes,
Right.
and that's an important component of the overall deliverable. But then the data that they are interfacing with, the infrastructure that the code is running on, the library dependencies that are sort of like being relied upon by the user code, all of that are equally critical. And within Metaflow, the programming paradigm that we have settled on is that our users, they are essentially declaring a DAG in either idiomatic Python or idiomatic R, and then they can annotate each of their nodes of the graph. And by these annotations, what I mean is that the user can go and say that, hey, this node in my graph needs to, say, execute on an instance with 200 gigs of RAM in the AWS cloud. This other instance of the node might want to execute just on my local laptop, and maybe I want TensorFlow to be available to that particular node. And then Metaflow will take care of orchestrating all of these different nodes of the graph, and it will move around all of these execution environments so that the user doesn't have to think about it. A simple example here could be, say, I have a 3-step workflow that I have written in Python. The first step might be reading data from a data warehouse, say, for example, S3, and it might be doing some sort of like feature engineering work. The next step might be relying on this data set to train a model. And then, say, the last step might be just responsible for stashing that model somewhere so that some other process can pick it up and do whatever is needed to be done with this model.
So those are all individual nodes. Would that be right?
Exactly. So all of these can be individual nodes. Now, this concept is not at all new, right? Like all workflow schedulers have a similar concept. But now what happens is our users, they declared this graph on their laptop and now they want to execute. And very soon what might happen is maybe the data volume is too high, right? Maybe you're processing, say, a 20 gigabyte data frame and your laptop just doesn't have the needed RAM to do that. Now, there are a bunch of different ways in which, you can essentially spill to disk, be a little bit creative in terms of your data processing so that you can fit that entire compute onto your laptop. But usually it's much more easier for a data scientist in terms of the amount of time that they are going to spend if they can somehow just lift and shift that compute onto the cloud where that compute just executes on a much bigger instance. So our user, in this case, they can just go and they can just annotate that node and they can say that, hey, this just needs to run on an instance with at least 20 gigs of RAM. And then Metaflow will just like take that compute and execute it behind the scenes for the user, and it will pipe all the logs to their laptop. So to the user, it would almost seem that their laptop just has more RAM at this moment. Now, behind the scenes, what Metaflow is doing is it will essentially take care of all the heavy lifting of like, okay, what Docker image to use, how to package your code, how to actually instantiate a remote instance, execute your code, bring back the results so that you as an end user never have to think about any of those concerns. You can just like very easily just keep on swapping the resource requirements that you need, and Metaflow will do its work for you. Now, let's say you executed the first step. Right. Now, the second step, you're training the model based on the features that you generated in the first step. And now, usually, what ends up happening is that, somehow the user needs to then decide how to pass data between these two steps, right? If everything is running locally on your laptop, then it's like much more easier. But then what happens if, let's say, one of the step runs on the cloud, the other step runs either on my laptop or a different instance on the cloud? And Metaflow by default will snapshot the entire state of the node and make it available to all the subsequent nodes. So that then again, the user doesn't have to think about state transfer between these nodes, and they can just like write their code assuming that these are all class variables and are available everywhere. And that sort of like again makes them a little bit more productive. Given that, Netflix has like significant investments in machine learning, we have many data scientists running like really high scale data pipelines, which make significant use of compute resources, and GPUs don't come cheap. So this also helps us isolate parts of our code that only need to run on like expensive instances, and other parts of the code can run on cheaper instances. So for example, in this case where I was playing around with the data, then training a model, and then stashing the model somewhere, maybe, like only the middle step needs to execute on a GPU instance, and all the other steps can run on just like the normal EC2 instances that AWS provides, which are not as expensive as the GPU enabled instances. And that also allows us to keep our cost profile significantly low.
That all totally makes sense to me. The idea that you want to take advantage of shared resources as you can. It's going to save a lot. It's not going to have a bunch of idle equipment or resources out there. To kind of dive into the nitty gritty a little bit, if someone was going to write those types of annotations, what does that look like? Are they doing that in Python, in some kind of markup language, or is it something specific inside of the language of Metaflow?
So this is all pure Python. So we decided to not go with any specific YAML-based DSL or any JSON specification, purely because it's like easier for people to read and write in a pure programming language. So right now, for open source Metaflow, we have all of the integrations predominantly for the AWS cloud. And the reason for that was because Netflix is an AWS shop. We have significant experience with that.
Yeah.
But we are seeing increased community contributions for integrations with GCP and Azure and other parts of the Kubernetes ecosystem as well.
Cool. So like somebody could be using some of those resources also. But the general idea of like, okay, I want this model to train with this set of resources, or I want to use this particular node to do sort of the data processing part of it. Mm-hmm. Those annotations are written just right in pure Python as part of the program that you've created. Okay, cool. DigitalOcean's App Platform is a new platform as a service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point to your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/realpython. That's do.co/realpython. Kind of building on top of that, this idea of snapshotting, which I think is totally fascinating, is how is the snapshot saved? Mm-hmm. And then I guess, how is it recalled? Like how does that kind of what does that workflow kind of look and feel like as far as the actual like writing of files and things?
Sure. Yeah. So what ends up happening in practice within Metaflow is that the runtime of Metaflow will take note of the entire state, and it will essentially pickle it and compress it and store it in the data store. So, for example, you can imagine the data store to be Amazon's S3, and we store that in a content address manner so that we can save on storage costs, even though storage is becoming cheaper and cheaper by the day. And when any node executes at that point in time, we can lazily recall any of these values when the code starts to execute on any of the instance. And the snapshotting, essentially, definitely one obvious benefit is that the user doesn't have to care about state transfer. But then there are other equally great benefits as well, given that the entire state is being stored in perpetuity. People can go back in time and they can replay any compute. If, let's say, their workflow ran into any error, then it's rather simpler and straightforward for them to figure out why the error happened, because everything has been snapshotted and the user doesn't have to go back in time and be like, hey, like if only I had added this yet another log statement or captured this another variable, because we are storing everything. So that just helps recovering from errors quite a bit simpler and straightforward. And also it helps in some sort of like memoization. So I can go back in time, I can modify some code, I can copy over the state for my previous steps, and then I can just like resume my execution as well. And all of those capabilities are usually helpful when people are debugging their workflows. And like you can imagine that Netflix has a bunch of workflows which have like super strong SLAs. So when things fail, it's rather critical for us to make sure that our users can not only detect the failure, but they can actually reproduce those errors so that then they can reliably fix it and move forward with their day.
I think it's such a strong part of science. I remember, diving into data science a few years ago and hearing, of sometimes the non-repeatability of experiments, sometimes based on just like packages or things being used. So that state being saved is really pretty powerful. I could think of it, not only in, the kind of scientific experiments that you guys are doing, but in like medical situations or other sorts of situations where this like real extreme repeatability is really crucial.
Mm-hmm.
And it just makes me think of like video games in a way. The idea of like, I'm definitely a person who saves a lot. It drives my wife crazy. She's into video games too, but I'm constantly saving, and I will go back in time sometimes and say, I want to go from this point when things were good,
yeah.
Sort of a time travel idea, and make that, make those decisions from there. And so I think that's kind of neat. And to use another video game platform kind of idea, this idea of crossplay. I don't know if you are into video games at all,
mm-hmm.
but the idea of like being able to take your saves and move them from one platform to another
mm-hmm.
kind of feels like a similar thing here, which is really kind of neat. The idea that you could potentially move your infrastructure, and you already mentioned the idea of going from a laptop to
mm-hmm.
pushing certain things up into the cloud. And to specify those resources, is that where the decorator sort of syntax kind of comes into place?
Yes, so we use we liberally use decorators for everything. So you can specify resources, you can specify execution characteristics. Like, do you want to like retry this compute and so on and so forth. You can specify what sort of like library dependencies do you want to use. Do you want to use like TensorFlow GPU, PyTorch, whatever package that sort of like gets your work done. And then given that, everything is happening in the Metaflow universe, so we can essentially index and manage this metadata information and provide some stronger guarantees of repeatability. And so another point, which is like rather important for bigger organizations, is that of collaboration. And this notion of repeatability sort of like becomes really important in that aspect. Like if let's say I have to build on top of my colleague's work, then the table stakes is that I should be able to repeat what they have already done, so that then I can reliably make changes and sort of like make forward progress. So that's where this aspect also comes in really handy for us.
Yeah, the idea of like handing off the project, or I'm going through an experience right now where I'm trying to take a vacation. Um, and the idea of like being able to like say, okay, I've done all these things. I've set up all these things are scheduled and they're supposed to happen. But to be able to sort of hand this project over where there's this extra level of documentation
Mhm.
that's happened where you've specified what hardware is supposed to do what and where, and then you've saved multiple sort of states as you've gone along, I think would allow inside of like you said, an organization to be able to, somebody to be able to pick it up and possibly, by watching or playing with some of these earlier versions of the project, they would be able to kind of learn too, like, okay, well, they tried this and then they tried that, and you can kind of then walk through the different
Exactly.
variations, and all those variations are saved. Is it saved in a way that, if it's possible, like I think of like the snapshots on a computer.
Mhm.
I don't know, like Apple has their time machine thing where it doesn't necessarily have to back up the entire computer each time.
Mhm.
It will just back up the changes. Is it something similar to that as far as the data usage?
Yeah, so we essentially don't save diffs at the moment.
Okay.
So we essentially look at like, okay, have we saved the similar information before? If we have, then we skip it and we just store a pointer to that similar information.
Mm-hmm.
Otherwise, we'll just like upload a zip copy of the information.
Okay.
And your point around like experimentation was absolutely spot on. ML or like building machine learning models, it's very iterative, and usually people will try out a whole bunch of different ideas. And given that we are snapshotting the state, we are storing all the metadata on behalf of the user, makes it rather simpler for them to sort of like just continue experimenting, and then they can go back in time and see which model behaved how, and then they can cherry pick what work they want to promote to production and so on and so forth, without actually doing anything specific by themselves.
I think of that as almost like a bit of a secret selling point, in the sense that, a lot of people would think, okay, well, it's going to, be the first answer of like, it's going to help solve a lot of your infrastructure problems and the portability problems. But underneath it, that might be a bigger win in some cases. Well, I mean, maybe with the data scientists themselves, I don't know.
Yeah. I mean, like what I have seen so far is usually people they struggle to sort of like put like a single model in production, and that's sort of like really really difficult and tricky. Like data science by itself is super tough field, and then dealing with infrastructure makes it doubly so. But then it's even a larger struggle when, let's say, the project actually pans out and your stakeholders start demanding more enhancements to the model. And now you essentially are on the hook for training a different model with, like, say, more features, while you already have yet another or the original model running in production, regularly being refreshed in production. And now you have to sort of like figure out, like, okay, how do I train a model alongside my production model? Okay, somehow you figure that out. Then you might want to decide that, okay, now how do I figure out this model is better than the production model that I already have? Bunch of different techniques. Maybe you want to run a live A/B test. Maybe you just want to do some offline back testing. And then you need to figure out, how do I promote this to production and yank out the previous model and track all the metrics and everything. And that suddenly becomes like super hairy.
I bet. Yeah.
And our approach is that like Metaflow should essentially take care of all of that. And as a user, if you are, say, training a model, or if you're doing any sort of experiment, then everything should happen in sort of like an isolated user space in some sense, so that you're not stepping over anybody else's work. And at any point in time, once you're happy with whatever you've done, then you can very easily just promote and swap out your models. And that usually, if you can sort of like provide those guardrails, those isolation guarantees to the end users, then they can do however they want to essentially structure their work, without actually having any fear that they might end up by mistake swapping out the model in production when they didn't want to, and like things of those types. So
yeah. So I have a couple questions that kind of do a couple steps back of the idea of like, okay, we talk about the cost of resources
Mhm.
and the data science, scientists hourly versus like the cost of what infrastructure is. Is that a conversation that goes up into the higher levels of management? Do you see that inside of the organization having those conversations?
So it hasn't happened as much. Usually, what ends up happening is that it's the data scientists who themselves are concerned about the infrastructure costs, and for good reason. Like some of these machine learning processes, especially if you're, as I said before, if you're using GPUs and all, they can cost some serious money. But then all of that also needs to be balanced against the business value that's being driven. And there have been instances where, like there are certain aspects of the cloud that are just becoming significantly cheaper and cheaper. So, for example, data storage costs are just like going down by the year. And I do remember this one incident where a data scientist came to me and they wanted to spend some time optimizing their workflow because their workflow was writing, I believe, like a terabyte big file into S3. And it was only supposed to run weekly. And they were planning on spending like almost a week to like re-architect their entire workflow so that they could avoid doing that right. And to them, it felt like a super expensive right. But if you sort of like calculate the amount of money that you would be spending on a data scientist spending a week optimizing their workflow so that they don't do this right of 1 terabyte file every week versus actually just going and writing that. I think the calculation was that it's like 2 orders of magnitude more
Oh,
the money that we pay to the data scientists for that 1 week compared to the overall storage cost that we might have. So that just goes on to say that there are certain areas where definitely some amount of efficiency wins are desirable, but then they also need to be balanced by the productivity gain. What is it? Like would you want a data scientist to spend your time sort of like optimizing for pennies? That just doesn't make sense in many cases. But yes, on the flip side, we also want to make sure that in areas where cost does matter, in those areas we are sort of like being judicious. For example, compute, even like when it comes to data storage, a single terabyte big file might not make much of a difference, but then if you sum it over all the data scientists, all the processes that are running, then it might become big. And so we do sort of like within Metaflow make sure that the platform can provide all of those guarantees around optimal usage of infrastructure to the best of its ability.
yeah. Think about that. Like just moving all the data around has got to be like one of the big bottlenecks of the whole, sort of situations. And then I would think that just even, I don't know, I guess there's not as much external data maybe within an organization like Netflix. There isn't as much data that's coming in that's like you're reading in some sort of public data or something like that. So uh, are there organizational things inside of Netflix where you guys are, structuring your data in specific ways to make sure that it is always optimized and manageable? Is that like a part of, does that fall into the infrastructure side of the situation?
Yeah, so Netflix has invested pretty heavily on the data infrastructure side of the house. So we have a very mature infrastructure on that end. And we use S3 as our data lake. So all of the data that's generated inside of Netflix finds its way in S3. And then we have a litany of query engines, Spark, Presto, Snowflake, that allow our end users to efficiently query that data. Now, one thing that we notice specifically for machine learning use cases is that our users, they essentially want to spin up a notebook, and within that notebook or within like whatever their favorite IDE is, they want to essentially get a shard of data and then play around with the data on their local instance. Like so they want to own the transformation rather than sort of like push it down to SQL and to a query engine. So then we ended up writing our own utilities to make sure that we can sort of like max out the throughput between our data warehouse and these EC2 instances that are running the user code, so that the user can get access to all the data as quickly as possible without actually going through the query engine. And we can also do some lightweight transformations over the wire. And it turns out that that's like one of the most well-loved feature of our machine learning framework internally.
Is being able to access those shards of data?
Being able to quickly access those shards of data without actually going through a query engine like Spark or Presto, because then you can get that data in a matter of seconds rather than matter of minutes. And that just makes iterating on your work a lot more enjoyable, because you can like very quickly just like change parameters and just like get going.
So the term data lake to me is still kind of nebulous. Like I'm somewhat familiar with the idea of like a data warehouse, which would probably, I feel like that would be a much more structured kind of thing. Can you describe, like, for somebody like me who's like, I'm not exactly sure what a data lake is?
Yeah, I mean, unfortunately, that's the issue with many of these terminologies, where a lot of people use these terms interchangeably as well. So in some sense, you can say that, yes, like Netflix's data infrastructure is built around a data warehouse. Another interpretation could be that, yes, it indeed is a data lake. So for us, we deal a lot with like structured data as well as unstructured data, given that we are in the movie production business. We do have a lot of raw video data, a lot of images, and so on and so forth, and all of that gets stored in S3. So in that sense, yes, we essentially use S3 as a literal blob store, and so you can say that, yes, that's the data lake that we have.
Okay, would it be? And so in that case, like if it's say a video or a movie, it would have, I guess all kinds of data inside of there. It would have everything from generic things like the title and the genre and some of the other kind of specificity in there. But then it would also have like the captions, sets of still images that you potentially would feature. All those kinds of things are contained in there,
as well as the actual movies and the images.
Right. Okay.
Yes. So all the metadata as well as all the raw information.
Okay. And so somebody pulling a shard out of the data lake could be, it's still a form of a query.
Yes.
In a sense, like they would be grabbing, like, okay, I want to grab this subset of that stuff. And does it use its own kind of language for pulling that out?
Yes. So usually, like when it comes to our structured data, all of that structured data is stored in the form of tables. So we use the iceberg table format for that. And our users, what they are usually interested in is, say, we have some data that's partitioned by date. Can I get the last 15 partitions of that table?
Okay.
And give me all the columns, or give me a subset of the columns. And because, like these are stored as like Parquet files, so we can very efficiently pull in like the needed columns for the users and present them.
This week, I want to shine a spotlight on another Real Python video course. It covers a topic of graphical user interfaces in Python, which we've touched on a few times now on the podcast. It's titled Simplify Python GUI Development with PySimple GUI. The course is based on an article by previous guest Mike Driscoll, and in the course, Darren Jones takes you through how to install the PySimple GUI package, create basic user interface elements, and then create applications, such as an image viewer. Then you'll integrate PySimple GUI with Matplotlib and computer vision. Finally, package up your PySimple GUI application for Windows. I think it's a worthy investment of your time to learn how to build graphical user interfaces in Python so that you can share your programs with others and move beyond the command line interface. Real Python video courses are broken into easily consumable sections, and the courses feature code examples for the techniques shown. And now, all courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. When you guys were creating this system, in adding the idea of all this metadata and the additional language kind of components of like versioning everything, were there any things inside of the organization that kind of blocked you from being able to do this, or like getting people on board to use it?
Yeah, excellent question. So Netflix has a culture of freedom and responsibility. So, which means that, like they're like literally like zero roadblocks in terms of if you want to get something done, as long as the idea makes sense, people have the complete freedom to exercise good judgment. And this applies not just to creators, but also users, right? So, for example, the infrastructure team, as a member of the infrastructure team, I have incredible autonomy to build things that I feel might be useful for our users. But then on the other end of the spectrum, our users, they can also exercise their freedom to either use what we have built out or go with some other open source alternative or with a commercial vendor if those seem to fit their needs better. So what that means in a nutshell is that even inside of Netflix, when we are building out infrastructure, in some sense, we are competing with sort of like best of the breed solutions that exist out there. And I have to constantly make that choice that, okay, is there something out there that sort of like provides much better value to our internal customers that we can just buy or adopt rather than building it out by ourselves? So Netflix is sort of like super big on this build versus buy methodology. And, like one of the biggest shining examples is our dependency on AWS, right? Netflix used to be within a data center, and then we saw that AWS can provide that undifferentiated heavy lifting for us and do an excellent job. So we decided to migrate completely on top of them. So as we were building Metaflow, like if you look at, say, the landscape of machine learning platforms 4 years ago, that looked very different than how it looks today. We didn't really have very many choices in terms of projects that we could adopt or, commercial tools that we could buy. And so that essentially meant that we had literally no other choice but to very closely observe our users, identify what their pain points are, what are those 1,000 paper cuts
Yeah.
that make their day difficult. And we just started addressing those one after the other. And, if you build something that is helping users sort of like be a little bit more successful, a little bit more productive every single day during their work life, then you start seeing adoption. So we did that. We saw massive adoption, almost universal adoption internally. And once we were at that stage, then we decided that maybe it might be a great experiment to open source Metaflow, see what sort of adoption the project gets in the open source community, and basically expand the pool of audience from whom we can learn from, and then iterate on the product and just like make it better and better.
So that sounds like there's a couple reasons why you decided to do that. Partly, in a sense, kind of giving back to this community, and in another way, you get a lot of additional testers and you get to see a lot of other interesting edge cases and get the feedback on those things, which can be invaluable.
Yes.
And potentially ideas. So when was the open source release for Metaflow?
So we open sourced Metaflow at AWS reInvent in 2019.
19?
Yes.
Okay.
So it's been roughly or like less than year and a half since the project has been open source.
And how's the response been?
It's been great. I mean, we have definitely seen companies from across the spectrum adopting Metaflow. They're like major tech firms in Silicon Valley and beyond, which are using Metaflow to power all of their machine learning. We have small startups, mid-sized companies across all industrial verticals. So the response has been great. And more importantly, it has also allowed us to understand the perspective that various people are bringing in. Now, the fact is that, 10 years ago, the number of organizations which were practicing machine learning was like really tiny. And now it's been democratized, which means that the best practices or how to get things done, it's still being discovered. People are still sort of like evolving their understanding of how things should be done. And given the fact that now we have this direct channel of communication with many of these folks in the community, that just allows us to learn better and get ahead of any sort of innovation that's bound to happen in this ecosystem.
Are there any specific things you can point to say, we decided to add this because of the outreach from others or the pain points that they were feeling?
Yeah, sure. So, for example, we think about some certain examples. So, configuration management, that happens to be like one of the key things. So, we heard from some of the bigger adopters of Metaflow around how they think about managing configurations within their ecosystem. And that learning has been helpful as we sort of like go about designing a better config management system for us. Then there have been companies which have been stress testing Metaflow in an entirely different dimension that we didn't do as much at Netflix. And that sort of like also uncovers certain areas of improvement, not just for Metaflow per se, but for AWS as well. And they have been an excellent partner as we went about open sourcing Metaflow as well. So it's been great to sort of like see feedback that improves not only us with the state of cloud computing in some sense as well. So yeah, that's been cool.
Cool. So I mean, that could be something like a project that's much more based around, let's say, maybe they're specifically doing like NLP kind of stuff, much more language and text kind of based stuff versus a lot of the video and other types of inputs that you guys have. Is that kind of what you mean?
Yeah, I mean, as you can imagine, right? Like, for example, let's say if you're a biotech company,
Oh, okay, yeah.
then the kind of data set that you might be working with and the kind of scale that you might be operating on and the kind of compute that you might be running might be a tad bit different than what a company like Netflix might be running at this particular point. So that sort of like helps uncover some of the areas for improvement for us.
And to go back to the configurations, that's really in this graph-like structure. That's the ability to specify, I guess, the different formats that these things can take on board, that they would have different architecture available to them, or maybe limited architecture. Is that kind of part of it, the configuration of like where things can be processed and used?
Yes. So now what's also happening with like many of the organizations is that they start building on top of Metaflow and sort of integrating with other business systems that they might have deployed within their organization. And at that point in time, they might want to provide either a limited set of functionality to their users, or they might want to provide a way such that, as you said, like all the decorators, all the attributes that Metaflow relies on in a much more cohesive manner. So I think there's like configuration management tools like Facebook's Hydra and so on and so forth that are like really popular in many of the organizations. So people would want to make sure that, yes, like Metaflow can play well with a lot of these other tools in the ecosystem. So that's what I meant by config management.
That makes sense. Yeah. Because so much of it is that the idea that all of this is very, you got to think about the extensibility, the ability to attach things and work in other workflows. I guess that makes sense.
Exactly. And, that's the value prop for Metaflow as well. So at Netflix, we have had the luxury of standing on the shoulders of the giants. So we have a data warehouse, we have a compute platform, we have workflow schedulers, we have model monitoring tools, we have dashboarding tools. And Metaflow was intended as this glue layer that sort of like allows people to move between all of these systems rather easily. And now the good thing is that with the advent of the cloud, all of these foundational infrastructure blocks are available as managed offerings. So, like when it comes to Metaflow, like we don't provide our own compute platform. We rely on your existing compute platform. We are not a workflow scheduler. We rely on an existing workflow scheduler like Airflow, Step Functions, Argo. And But then the interplay between all of these systems, that's not really that straightforward. Like what we observed was people, they might be able to write their code or execute their training jobs against the training platform. But then once they have to productionize the training workflow, then they'll have to re-implement everything within Airflow, within step functions, within favorite workflow scheduler. And how do we sort of like get to a point where, people don't have to think about all of these different transformations? And that's been really helpful for us in terms of just like providing that glue code so that all of these concerns are taken away, and we can then essentially bake in all of our many years of hard-earned expertise with all of these systems and best practices in the machine learning engineering ecosystem.
The documentation that you created for Metaflow is, usable on multiple levels, like in the sense that when you have a new employee come on board and they're going to work in the data science team, and you need to introduce them to this technology of what Metaflow is that something that would help them get on board in a sense too, to like, okay, these are all the different kind of moving parts and this is how it kind of connects together. I'm guessing you probably have your own additional documentation, but
No.
Is that something that you share internally too?
Yeah, I mean, like the documentation that you see in open source is pretty much the documentation that we have internally. We do have some additional functionality that is Netflix specific that is not yet open source, but is in the process of slowly being made public as well. But yes, you're right. Like our expectation is that even if you are sort of like a new user or an old existing user, you would essentially come to our documentation to sort of like get started or sort of like figure out like the nitty-gritties. But beyond that, with this project, or at least like the open sourcing of this project, the goal was not to showcase engineering skills and just like make some code base public. But the goal was to learn from users, help users in the community as well as internally. So there's a strong focus on providing good support experience as well. So, if let's say you are a user of Metaflow, or if you want to use Metaflow, you can come talk to all the devs at chat.metaflow.org. And there's a very vibrant community. And we want to understand what are the pain points that the users are facing and how can we help them, and not necessarily how Metaflow helps them with those pain points. And that subtle difference then allows us to sort of like figure out what is it that we build next, so that then we can continue providing that leverage and we wouldn't have to address those same issues over and over again.
Yeah, I was thinking about people getting started in the industry, because that's kind of the idea behind Real Python, is really kind of helping people not only learn Python but learn all the tools and the different things that are available to them. And I think about infrastructure a lot. We've had a couple things where we've talked about sort of data engineering and kind of that as a sort of separate path. A lot of people I've talked to have sort of fallen into that career. Like it's kind of like that seemed to be what opened up for them. Do you think learning these types of tools, even at a nominal level, is something that an employer would be excited about? Like, seeing somebody come on board and have somewhat familiarity with, not only some of the infrastructure stuff that's needed to do the data science, but like, these are some of the tools that kind of connect it together. Do you think that's a useful additional feather in somebody's hat as they go to like look for a job, to be familiar with tools like this?
Sure, yeah. I mean, like familiarity with the tool helps, but I think one of the bigger value proposition of anybody, like who is interested in this area is what are the problems that these tools are actually intending to solve.
Yeah.
I think that's sort of like the biggest value prop in terms of understanding the landscape. Many of these problems, they are hard to speculate if you have not worked in this field. So if you're brand new, if you're looking at, Metaflow, then I would highly recommend just looking at it in terms of like, okay, what are the problems that it's solving? If Metaflow did not exist, if other comparable tools did not exist, then how would you go about solving the same set of problems? And I think that will help build real appreciation for some of the pain points. And that's always useful for employers.
Yeah. I think so too. Kind of go on a personal level. What made you interested in working in this realm and in infrastructure and building these types of tools?
So I was always personally excited by math and data. So that's why, when I was graduating, it felt like, finance might be a better fit for me. But serendipity brought me to Silicon Valley. and then, as I mentioned before in the show, I thought, okay, maybe, like applied machine learning or being a data scientist would be super fun. And that's when I realized that, okay, to get my job done reliably in a disciplined manner, I need some infrastructure to be available to me. And because ever since then, I've been just building that infrastructure. And hopefully one day I'll get to do data science.
Do you still dabble in data science? Is that still like a common pursuit for you?
It is, but I think I'm still mostly on the theoretical side of the house. I think I find much more joy working with mathematical proofs these days rather than working on applied ML problems.
Cool. All right. Well, I want to ask you a couple questions that I have that are sort of my weekly questions.
Sure.
And the first one is, what's something that you're excited about in the world of Python right now?
That's an interesting question. On the ecosystem side of the house, I definitely really like the fact that, many of the open source projects are evolving to a point where community is sort of like a big aspect, and the communities are also becoming more and more inviting, especially for newcomers. I mean, when I started my career, like posting something on a public forum would give me anxiety because I was like, okay, I'm not sure, like this might be a dumb question and I'm not sure how people are going to react. So things have improved significantly over the last very many years. And that's definitely, like one thing that's super exciting. We still need to make a lot of progress in terms of just making sure that people who are building the products, people who are using the products, there's a good representation in terms of diversity, background, diversity of thought. And there's this progress being made, but there's still a lot more that needs to be done. So I'm hopeful on that front.
Yeah, sure. Totally. So what's something that you want to learn next?
What's something that I want to learn next? So I am pretty deep in horology. So these days I'm learning how to assemble and disassemble a watch. So that's something that's high up my list in terms of just like getting better at and getting a good hang of.
So I have a question on that. Would it make sense to start at a larger scale, like a table size, like a table clock or a wall clock, and then move toward a watch, or is it does it not matter?
So it's actually pretty difficult to find a mechanical pocket watch these days.
Yeah, I bet.
Unfortunately. So as much as, it would be nicer because you would be working with pieces that are significantly bigger in size compared to a normal wristwatch, I haven't actually found sort of like a pocket watch that works reliably and is in my budget to sort of like smash out. So unfortunately, I'm stuck with wristwatches, but it's fun.
Is there a particular brand that is a great one to play inside of?
I mean, I just go on eBay and I just buy like really crappy looking old watches where the seller is like, yeah, these ones, aren't going to work, so do whatever you want with them.
That's cool. Yeah. And then mostly like mechanical wound kind of thing, or are they battery ones too?
No, mechanical wound. There's a certain beauty in that, right? Like, yeah. If you look at it, it's like a great mix of art and technology.
Yeah, definitely. That's cool. Well, I want to thank you so much for coming on the show and talking to us about Metaflow and everything else.
It was my pleasure indeed.
All right, thanks.
Thank you.
And don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. That's do.co/realpython. I really want to thank Savin Goyal for coming on the show this week. Make sure you check out the show notes to learn more about the project. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.